Alright, good day and welcome back to the Division of Education, Innovation and Energy's e-learning program. I am Mr. Atwell and today we're continuing with consumer arithmetic. Now our last session we looked at simple interest, right? We looked at interest and we spoke about the fact that interest is the money gained based on use of money, or the interest is the money gained for using money. And we would gain interest if we allow our money to be used, and we would have to pay interest if we use someone else's money. Now, we looked at one specific interest last time, and that was simple interest. And can we remember the formula for simple interest? I hope so. Let's see if we can write it down. We should remember that simple interest is found by the principal, which is what? What's the principal again? All right, principal is the initial amount you would have borrowed or invested times the rate, right? And the rate is in whatever period times the time. And what is important here is that the rate and the time must be in the same period, all over 100. Yeah? Cool. Let's go. So let's have one question just to kind of recap on what we would have done before. So it says, the simple interest on $400 at 5% per annum for 2 years is given by one of these particular ratios. Now what are they asking us to find here? They're asking us to find simple interest. So we know that simple interest is principal times rate times time over 100. So, what is this number? Well, the simple interest on that amount. So it seems that this number should be our principal at 5% per annum or per year. So this is our rate. And it means then, since our rate is in per year, we want our time to be in years. And since our time is already in years, business fixed for us. So let's go. Principal, 400 times the rate, which is 5, times time, which is 2 over 100. Which one of those happens to look like that? Oh, that's A. So you see, again, when it comes to it, it's simply about applying the formula. And remember, sometimes it may require us to transpose a formula if we don't want to remember the others. And that is totally fine. All we have to do is continue to practice, and I will encourage you to continue to practice using simple interest. However, today, our focus is on compound interest, to know what it means, to be able to use the formula and understand the difference between what is called appreciation and depreciation while solving questions. So let's get into today's lesson. Compound interest is the interest calculated on the current balance of a loan or investment. Now remember what simple interest is, right? Simple interest is the interest calculated on the initial amount. Always on the initial amount. However, compound interest is on the current amount. You see the difference, right? So, whereas simple interest, simple interest never apply to additional interest you may have gained or interest you may be owing, compound interest, however, applies to all of the interest you would have gained over the time period before, or all of the interest you may be owing over the time period before. So it's important to understand the difference between simple interest and compound interest. So let's kind of get into it. So let's take an example. And we're going to be writing in some values as we go along. So it says Jim invests $100, which receives a compound interest of 10% per month. How much would his $100 be worth after, well, we have 1 month, 2 months, 3 months, 4 months, 5 months. So let's take it step by step. We're compounding, right? So we want to know how much will Jim's initial $100 be worth after 1 month? Well, we know that Jim is getting 10% per month, right? So the amount before the interest was applied for the first month, he started with $100. Boom. Let me erase that right there. Nice. $100. Nice. Now, he is going to get 10% of that amount as interest. So we know 10% is the same as dividing by 10. So 10% of $100 is $10, which means after the interest is applied, his new balance is now $110. Well, what about month 2? Well, how much did he start month 2 with? He didn't start month 2 with $100. He started it with 110. And this is where compound interest begins to differ from simple interest. Because if it was simple interest, then the interest for that month would have been an next $10, right? Because it would be 10% of the principal. But compound interest is always applied to the current amount. So since the current amount is now 110, then 10% of 110 is 110 divided by 10, which is simply going to be $11 instead. So how much is the total in his account now? Well, principal plus interest is the amount, so that is $121. What about month 3? How much did he start with? Well, he started with $121. What was his interest for that amount? It will be 10% of the amount, the current. So it's 10% of 121, which will be $12.10, putting your total to $132.10. You're seeing the difference, right? Because watch, if it was simple interest, if we had said it was simple interest, and I was going to write simple interest on the side here just to get a comparison, we know that every month would have been $10, right? We know that, principal by rate by time. So this, at the amount, simple interest at the end, here would have been 110, here would have been 120, then it would be 130, then 140, 150. Simple interest was simple. But you realize with compound, what starts to happen? The overall amount begins to increase beyond what's going on. So let's check the next two real quick. How much did he start month 4 with? He would have started month 4 with $132.10, and then he gets 10% of that as interest, so that's $13.21. And then here, we have to add them together, so 132 plus 13.21, so here we go, 1, 3, 5, 4, 1. $145.31. You see any difference? Instead of getting 140, you end up getting 145. And let's just do the last one. So we started with $145.31. He gets 10% of that, so that's $14.53. And so when we add that, we would get $159.84. Now, I want us to be aware of this, because when it comes to the banks, even though we may use dollars and cents, right? So that's up to the second decimal place. Banks use up to the fourth and even the fifth decimal place when it comes to recording your money. So even though you might open your account and only see $14.53, it will actually be $14.53 and that extra, 0.1 of a cent. So what we want to recognize here is the difference between the simple interest and the compound interest. And you realize something, that if you are applying interest on your previously gained interest, you get more money as you go along. Similarly, if interest is being applied on interest you owe, it means that you will have to pay more in the long run. And I want us to remember that. Now this year, we realized that the $100 that we started off with would have increased in value. Yeah? We started with $100, and then after 5 months, that same $100 is now worth $159.84. This is what we call appreciation. It is appreciation when the value of our dollar has increased over the time period. Yeah? But what about this one? So Jim bought a car of $50, and every year the car loses 10% of its value. Well, because the car is losing its value, the $50 spent on the car, the $50,000, spent on the car initially, the car will not be worth that as we go along. So what's going on here? Because the car is losing value, this is called depreciation. So appreciation, gaining value. Depreciation, losing value. Yeah? Now let's go through the question. So Jane bought a car for $50,000. Every year the car loses 10% of its value. So at the value of the car within the first year, it would have started off at 50 grand. But then it lost 10% of its value, or 10% of its current value. So 10% of its current value, 10% of 50,000, we know just dividing by 10, so that's what we get, 5,000, which puts the new value of the car at 45,000. So it means then, at the end of when it comes to the second year, the value of the car would have no longer been 50,000, but it would have been 45,000. Yeah? So it means then that the car is going to lose 10% of that value by the end of the year. 10% of 45,000 is 4,500, which is then 40,000, 500. Let me make this 5 look a little bit better. Yeah? Now, what's going on? Here we have the car being worth 40,500. It's going to lose 10% of this value, so now it's going to go down to 4,050. So the value of the car now goes to, what's that? 36,450. Similarly, month 4, it began being worth 36,450. It then loses 10% of that value. 10% of that is 3,645. Yeah? So then the value it goes down to will be 36,450 minus 3,645. Let's just do that real quick. So 5, 8, 2, 3. $32,805. And similarly, the last step, same thing. The beginning of year 5, the car was now worth $32,805. It lost 10% of that, so that's $3,280.50. And now we'll have to take away $3,280.50 from that. So 3280.5 take away. So that's, boom, that becomes 4, that becomes 5, that's 5. Doesn't want to write. So there are 4, imagine that's a 5, right? There we go, there we get the 5. So then this comes 7, that goes there, 10 take away 8 is 2, and 7 take away 2 is 5. 2 take away 3 you cannot, 12 take away 3 is 9, 29,524.50. So after 5 years, the car that was worth $50,000 is now worth $29,524.50. Now, if it was simple interest and every year it was losing 10% of the value, saying that every year it was going to be losing $5,000, then here would have been 45, then here would have been 40, then it would have been 35, 30, 25,000. Now, again, it's important to understand the difference between simple interest and compound interest. Because as we're depreciating value using a compound interest, we actually end up losing less as we go on. But if we're depreciating value using simple interest, we actually end up losing more. And the inverse is also interesting, that if we're appreciating in value, simple interest will appreciate less than compound interest will. So it's kind of interesting, and it's just to understand. So when it comes to compound interest, just understand that every single time you're going to calculate your interest, it's about the current amount. It's on the current amount and not the initial amount. Yeah? So always remember, when it comes to compound interest, it is always important to remember that it is always applied to the current amount and not the principal amount. Yeah? Compound interest is always applied to the current amount and not the initial amount. Understand the difference? So let's go. Is there a way to calculate the amount after a certain number of years without having to actually go through and calculate the new principal each year? Instead of having to do all of this drama, is there a formula? Is there something that we could do instead of having to do all that hard work? Come on, this is mathematics. Of course, there's a formula for compound interest. So here we have the wonderful formula. The formula for compound interest looks nothing like the formula for simple interest. The formula for simple interest is principal times rate times time over 100. But look at this formula for compound interest. Why are they trying to hurt my head? No, don't go so. Just take your time. Let's go through it step by step. Now, the first thing that you must realize is that instead of interest being the subject of the formula, as it is for simple interest, here, what we find is not the interest, but we find the final amount. So it means that when we use the compound interest formula, we're actually determining the final amount and not just the interest that you would have gotten. P still represents the principal. 1 plus R represents the rate, and T represents the time or the number of time periods. And it's just about applying this particular formula. Now, why we're saying this is a compound interest formula, but it doesn't give us compound interest? That don't make any sense. Well, what we have to remember is all we have to do is remember that the total amount or the final amount is principal plus the interest. So, if you know the final amount and you know the principal, then to find the interest, it will simply be the final amount take away the initial amount. Principal amount, minus principal. Interest is simply the change between how much you would have started off with and how much you would have ended off with. That's what interest is. No big hard mathematics there, right? So don't make it more complicated than it needs to be. Let's look at this question. So it says, how much interest is earned when $800 is invested? So if we invested $800, this means that this automatically becomes our principal. All right. At 10% per year, what is this? This is our rate, and it is compounding over 2 years, or the interest rate is applied for 2 years. So this is our time. Now, again, remember, when it comes to interest, you must remember that the rate and the time must be within the same period. So because this is per year and this is 2 years, we in business. If it was being compounded per month, then we will have to find this in months. Good. So we want to find the interest, and it's compound. So it means that we have to find the amount first. First thing to do, let's write down our formula. Amount is the principal times 1 plus the rate, close brackets, to the time. Now let's substitute our values. We don't know the amount, so we just write back the letter. Do we know the principal? Well, yeah, we do. So that's 800 plus 1, open brackets, 1 plus the rate. Now, what is important here? And this is the difference, like the next difference between simple interest and compound interest. What is important here is that the rate is not as a percentage, but as a decimal or a fraction. So we can write it as 10 over 100, because that is what 10% means, right? To the power of the time, which is 2. So 801 plus 10% is simply 0.1, right? Just by dividing. So that becomes 800. What is the first thing we should work? The brackets, right? Because remember, order of operations, yeah? Brackets, powers, division and multiplication, addition and subtraction. This is the order in which we do operations. So the first thing we'll have to work is the brackets. So 1 plus 0.1 is 1.1. And then that will be squared. Boom. Brackets done. Next thing we have to work. Powers. So it will be 1.1 squared. So that will be 800 times 1.21. So how you do that? Well, everybody know 11 times 11 is 121, right? And remember that when you're multiplying decimals, simply how much of a decimals you will have in your initial multiplication, that would be the amount in your product. So since it will be 2, this becomes 1.21. Don't make the math harder than it needs to be. Yeah? So then it becomes 800 by 1.21, and then we could make this a whole number, bap, and go bap. So it becomes 8 by 121, 121 by 8, that simply becomes 968. So the value of that $800 after 2 years is now 968. But this is what they ask us for, because this is what? This is the amount. This is not the interest. But they asked us for the interest. So how do we calculate the interest? We go back, we look at the formula, we realize that amount is principal plus interest. So we go amount is principal plus the interest. We know the amount is 968, the interest is 800. Sorry, not the interest is 800, the principal is 800, and the interest we don't know. So how would we find this? Of course, we have to transpose, right? So that the interest is then going to become 968, take away 800, which is $168. Yeah? It's a step-by-step process. So you have to take your time and work it through. If you know your formula, just make sure that your rate and your time are in the same time period. That is the key when it comes to simple interest, when it comes to compound interest. Your rate and your time must be in the same period. So if your rate is per year, your time must be in years. If your rate is per month, your time must be in months. If your rate is per day, then your time must be in days. That is the key. If you could remember that, no problem. How about this one? Ooh, numbers starting to get harder and harder. And you're going to realize something as you go along. So as you realize this, as you do this question, you're going to see something. So it says, if you deposit $4,000 at 5% annual interest compounded quarterly. Whoo! That already sounds confusing. 5% annual interest compounded quarterly. How much money will be in the account after 3 years? Now, let's go. So our principal is $4,000. What is our rate? Now I know we just read the question and it just sounds so confusing, right? It says 5% annual interest compounded quarterly. What in the world does that mean? Well, it means that for the year, the interest will be 5%. However, the compounding period is not per year. The compounding period is per quarter. So it means that we have to find our rate per quarter. How much is a quarter? A quarter is every 3 months or 4 times a year. So if the annual rate is 5%, then it means that the quarterly rate is 1.25%. A quarter of the annual rate. Yeah? Cool. Now, how much money will be in account for 3 years? Now, what is the time? They say the time is 3 years, but what remember? We are compounding how often? Quarterly. So it means that there's interest is going to be applied 4 times a year. So if interest is being applied 4 times a year, and it's been applied for 3 years, how many times does the account experience a compound interest? Well, it will simply be 4 times 3, which is 12. Take your time. Let's read it from the top and go again, because I know some of you all would have gotten a little bit confused with that. It says if you deposit 4 grand, right? It says a 5% annual interest rate. However, it's telling you that even though it's a 5% annual, interest is going to be applied every 3 months. Compound. Yeah? It means that we have to look at the rate and the time in terms of the compound period and not in terms of whatever number they put it in. So it means that we have to find the rate per quarter. Well, we know a quarter is 4 times, right? 4 parts in a whole. So if it's quarterly, it means 4 times a year, which means that the rate will be a quarter of the annual. So when we divide 5 by 4, we get 1.25% per quarter. Again, what is important is that they're in the same period. Everything must be within the same time period. If it's not in the same time period, your calculation will be incorrect. So we need our rate in the quarterly. We need our time in the quarterly. Now, because we know we're compounding quarterly, it means that for every year that passes, we will have 4 compounding periods. Since it's 3 years, it means that there will be 12 compounding periods or 12 quarters. Yeah? What is important? That the rate and the time all be within the same period. Everything that we're speaking about must be within the same time period. Since it's compounded quarterly, everything must be referenced to quarter time period or quarterly time period. So now the amount will be principal, open brackets, 1 plus the rate to the power of the time. So then that becomes 4,000. Sorry, my apologies. It's not 4,000. The amount is 4,000, open brackets, 1 plus the rate, 1.25 over 100. Because remember, you want it as a fraction, not as a percentage, to the power of the time. Now, so that becomes 4,000. 1 plus 0.0125. This is supposed to be a 5. So let me write it a little better. To the power of 12. So that's 4,000 by 1.0 to the 12. Now, are you expected to be able to work this out in your head? No. All right? This is where, when you have a question like this, you'll be given a calculator and you'll punch in the answers and you will get the answers out. I can't even work this out in my head. Yeah? I know some of you all can because some of you all are geniuses and math whizzes, and that's great. Kudos to you. But I know the average person, we can't work this out in our head. We will actually have to get a calculator. So let me get my calculator. Now, if we were to look at it, all we're going to do is work our powers first. If you don't know how to use your calculator, you need to know how to use it. Now, I know that for your exam in August, that's for mathematics paper 1s, you're not allowed to use calculators. But compound interest is something you need to be able to use for life, especially when it comes to loans, when it comes to investments, when it comes to whatever finance. Working with finances on a whole, it is important that you understand this principle. I am not just here trying to teach you for July, August. I need you to understand something for life. So let's go. So We pull up our calculators real quick. Bap, bap, bap. So then we have 1.0125. 1.0125 raised to the power of 12. Yeah? And then we multiply that. So when we raise that to the 12, it becomes 4,000 times 1.16. So then it becomes 4,000 times that wonderful number. 4,000 times 1.16. 4,640. So if you deposit $4,000 at a 5% annual compound, so 5% annual interest compounding quarterly after 3 years, the amount will now be 4,640.